All right, today we're diving into a cosmic detective story, a mystery that honestly almost broke physics. For decades, two little spacecraft at the very edge of our solar system just refused to play by the rules, and it got so weird that some scientists started to question if we really understood gravity at all. This is the story of the pioneer Anomaly.
So, picture this. It's the early 70s, 1972 and 73 to be exact. NASA launches these two incredible probes, Pioneer 10 and Pioneer 11. Their job was to take a grand tour of the outer solar system, and they gave us our very first close-up looks at Jupiter, and for Pioneer 11, Saturn II. But after they flew by the planets, they just kept on going, becoming our first ever messengers to interstellar space.
Now, what made these probes so great for the navigators back on Earth is that they were spin-stabilized. You can literally think of them like a spinning top, just coasting through space. This meant they could fly for years and years, antennas pointed right at us, barely ever needing to fire their thrusters. And that super clean, quiet flight made their paths incredibly easy to predict. Scientists thought they could pinpoint their location with unbelievable accuracy. Well, or so they thought.
But then, right around 1980, things started to get a little weird. The probes were way out there, past Saturn, more than 20 times farther from the Sun than we are. And in that deep, dark quiet, Mission Control noticed something was off. The radio signals they used to track the probes, well, the numbers just weren't adding up. A tiny but very persistent error had crept into the data.
It was almost like some invisible cosmic string was gently tugging them back toward the Sun. Now, the deviation was tiny, a few thousand kilometers over the billions they'd already traveled. But here's the kicker. It was there, it was constant, and it was happening to both of them. For a physicist, that's not just a rounding error. That's a massive puzzle that makes you question everything.
So this ghost in the machine got an official name, the Pioneer Anomaly, and the investigation it kicked off would push the absolute boundaries of science, because really, the stakes could not have been higher.
So just how big was this ghost force, anyway? Well, the Anomaly was this extra little pull toward the Sun, an acceleration of about 8.74 times 10 to the minus 10 meters per second squared. I know, that's a completely absurd-sounding number. To put it in perspective, imagine you're driving your car, and over an entire decade, your speed drops by just 1 kilometer per hour? That's the scale we're on here. It's next to nothing, and yet it was absolutely there.
But see, next to nothing really adds up across the vastness of space. After just 1 year, that tiny little tug meant the probes were about 400 kilometers closer to the Sun than our best models of gravity, the laws laid out by Newton and Einstein, said they should be. And a 400-kilometer gap, that's a huge hole in our understanding of how the universe works.
This little deviation left scientists with two pretty mind-blowing possibilities. Possibility one, there was some totally mundane, overlooked force acting on the spacecraft that nobody had thought of. Or possibility two, our entire understanding of gravity was wrong, and the physics textbooks needed a major rewrite.
So, the cosmic detective work began. Investigators started lining up all the usual suspects, and they pretty much fell into two different camps: conventional, boring forces, or brand new, undiscovered physics.
You can really see the two lines of thinking here. On one side, you have the mundane causes, things like tiny gas leaks from a thruster, or drag from the solar wind, or maybe even heat coming off the spacecraft unevenly. Then on the other side, you've got new physics, and this is where things get wild. We're talking about modified theories of gravity, the idea that time itself was accelerating. Pretty much everything was on the table.
So naturally, the team started with the simplest stuff first. Could it be drag from space dust or the solar wind? Nope, space is just way too empty out there. What about a tiny fuel leak? It's possible, but for it to produce the exact same constant force on both spacecraft for decades, that's a real long shot. One by one, the easy answers just got crossed off the list.
But those new physics theories had a huge problem of their own. See, if this was some new, undiscovered feature of gravity, it should affect everything. Planets, asteroids, the whole shebang. But when astronomers looked, the planets in our solar system were orbiting exactly where Einstein's theories predicted they should be. It seemed like this weird new force was only affecting the Pioneer probes, which makes a new universal law of physics pretty hard to swallow.
So, with the simple explanations exhausted and the grand new theories hitting a wall, investigators had to turn their full attention to a suspect that they had considered but mostly dismissed early on: the spacecraft's own waste heat.
And this brings us to a neat little concept called thermal recoil force. It's actually basic physics. When something radiates heat in one direction, which is really just shooting out photons or light particles, it gets a tiny push in the opposite direction. It's like an incredibly weak rocket engine powered by light. So where was all this heat coming from? Well, from the probe's nuclear batteries, called RTGs. They used decaying plutonium to create electricity, and they kicked out thousands of watts of waste heat in the process.
So here's how it all fits together. First, the RTGs are just constantly generating all this waste heat. In the vacuum of space, that heat just has to radiate away as light. But because of how the spacecraft was designed, with that giant antenna dish on one side, more of the heat was being radiated forward, away from the antenna. And that uneven radiation creates a tiny but constant recoil force, pushing the spacecraft backward, right toward the sun. The theory was perfect, but proving it, that was going to be a whole other challenge.
To prove the thermal recoil theory, you needed more than just a good model. You needed data, and tons of it, stretching back for decades. So to crack this case, scientists had to become digital archaeologists and go on a huge data recovery mission.
This timeline really shows you just how long this mystery hung around. It was first noticed way back in 1980, but the serious investigation didn't really get going until 1994. The real breakthrough, though, came in 2006. That's when a team at JPL, led by a scientist named Slava Turyshev, actually recovered and digitized decades of old data from these ancient magnetic tapes. All of a sudden, they had more than twice as much data to look at as anyone before.
And guess what they found buried in all that old data? The smoking gun. The anomalous force, it wasn't constant. It was slowly, but measurably, decaying over time. This discovery changed everything. I mean, a fundamental law of physics isn't supposed to just fade away.
That decay was the key. The old model, which assumed the force was constant, never quite fit the long-term data. But a new model, one where the force decayed over time, it fit the data beautifully. And the best part? The rate of that decay perfectly matched the expected drop in heat output from the nuclear batteries as their plutonium fuel got older. It all lined up.
And just like that, all the pieces clicked. With the smoking gun of a decaying force now in hand, the scientific detectives could finally close this decades-long case.
In 2012, Turyshev's team published their final paper, and their conclusion was totally unambiguous. The quote really says it all. Quote, "Once the thermal recoil force is properly accounted for, no anomalous acceleration remains. The ghost in the machine was just the machine itself."
So what are the big takeaways from this incredible story? Well, first, the Pioneer anomaly was a real thing. It was a measured effect, not just some math error. Second, the cause was actually something pretty mundane, the spacecraft's own heat. But I think the most important lesson is about the value of just keeping your old data. This entire mystery was solved because a dedicated team went back and painstakingly recovered info from old magnetic tapes. It's a great reminder that sometimes the biggest discoveries aren't out there, but buried in our own archives. So in the end, the solution wasn't some exotic new theory of gravity. It was found on old magnetic tapes sitting in a lab. And it really makes you wonder, doesn't it? What other huge cosmic secrets are just sitting there, hiding in all the data we've collected over the years, just waiting for a fresh pair of eyes to come along and rediscover them?